What is the result when you multiply 2 to the third by 2 to the fourth? What's your guess? Let's explore. In this lesson, you will learn how to multiply two or more exponential expressions by exploring and generalizing a pattern. Let's review. An exponent tells you how many times to multiply a base number by itself. So a multiplication statement like 2 times 2 times 2 times 2 times 2 can be rewritten in exponential form as 2 to the fifth power, where 2 is the base and 5 is the exponent, also known as the power. Also, the associative property of multiplication states that you can regroup numbers in a multiplication sentence. Notice that this property states we can either multiply a times b, then multiply the result by c, and it will be the same as if we multiplied b by c, then multiplied the result by a. Here's an example with actual numbers. If we multiply 2 by 3, we get 6, then we multiply that by 4. Or if we multiply 3 by 4 first, we get 12, then multiply that by 2. Either way, we get 24. Back to the original question. Here I have written each of the exponential expressions in parentheses with no operations in between. Anytime two parentheses are written next to each other with no operation in between, the operation is multiplication. Often, students think that 2 to the third times 2 to the fourth equals 2 to the 12th because they multiply the two exponents. Or they think that the answer is 4 to the 12th because they multiply the bases and the exponents. But we'll quickly find that neither is correct. We know that 2 to the third power means 2 times 2 times 2. And we know that 2 to the fourth power means 2 times 2 times 2 times 2. Since we are multiplying these two expressions, we can simply write them next to each other. And now, using the associative property, we can regroup it so that instead of multiplying the twos in separate parentheses, we can multiply them one at a time in one big parentheses. So we see 2 multiplied by itself 7 times. Knowing what we do about exponents, we can write this more simply as 2 to the power of 7. So 2 to the third times 2 to the fourth was not 2 to the 12th as some might have expected because we are not multiplying 2 by itself 12 times. The answer is actually 2 to the 7th. We can verify this by actually completing the multiplication for each exponential expression. 2 to the third means 2 times 2 times 2, 2 to the fourth means 2 times 2 times 2 times 2, and 2 to the 7th means 2 times itself 7 times. 2 to the third ends up being 8, while 2 to the fourth ends up being 16, and 2 to the 7th is 128. 8 times 16 is 128, so we get the same result either way. Now, 2 to the third times 2 to the fourth is equal to 2 to the 7th. Do you see a pattern here? Notice that the exponent on the product, 7, was the same as the sum of the exponents in the original multiplication sentence, 3 and 4. This makes sense because we multiplied a total of 7 2's. This will always happen when multiplying exponential expressions with the same base. The new exponent is the total number of times you are multiplying the base by itself. Here we have b as a base multiplied by itself a times. Then that result is multiplied by b as a base multiplied by itself c times. A plus c just represents the total number of times we use b as a base. Here's an example. We are to simplify this expression by rewriting it as a single exponential expression. First, notice that the base of both exponents is 10. So I want you to visualize expanding this to 4 10s in a multiplication sentence times 7 more 10s in a multiplication sentence. Once we do this, we see 11 10s in a multiplication sentence. My hope is that you soon start visualizing this expansion on your own, and you can see that you can just take the sum total of 4 plus 7, or get 10 to the 11th power. In this next example, notice that both of the bases are some number x. So I want you to visualize expanding this into 3 x's in a multiplication sentence times 15 more x's in a multiplication sentence. Can you see the string of 3 plus 15 x's, or 18 x's in a multiplication sentence? So the answer is x to the 18th. Be careful with this last example. Notice that 2 of the 3 bases are the same, they're 4, but the third base is a 2. So we can use the commutative property to reorder the problem so that the two similar bases are right next to each other. We now see that we'll add the exponents on the 4's and get 4 to the 8th, but 2 to the third has to stay separate because it has a different base. So this is our final answer. In this lesson, you have learned how to multiply 2 or more exponential expressions by exploring and generalizing a pattern.